Hi, everybody. Welcome to topic 19, discrete random variable and expected value. So after we went over a lot of probability questions and accounting problems, I want to now introduce your next big set of materials, which is talking about random variables. So I'm going to start out with this thing called discrete random variable. So as you can recall, back at the beginning of this course, we talk about quantitative data and discrete data. So here we're going to begin to focus on this thing called discrete data or quantitative discrete data. So as you can recall, discrete data are quantitative data that can only take on particular value and are usually involving with counts. Okay, the data that is finite or it is countable. So I copied this from the previous topics that we discussed at the beginning of the semester. All right, so that's what discrete data is. So what a random variable, okay, so this is a new word. A random variable is a variable whose numeric value is determined by the outcome of a probability experiment. Okay, so what is so-called a probability distribution is a table or formula that gives the probability of every value of random variable x. So a lot of type of problems, a lot of example that we're seeing before we talked about the probability questions and accounting problems, a lot of them is now going to turn into a type of probability distribution. And then I will begin to kind of show you that as well. So here is basically we are combining the concept of probability along with a lot of our frequency distribution that we looked at before together, okay, call them probability distribution. All right, so probability again is between 0 and 1, okay, the sum of all probability got to equal to 1, okay, the sum of all probability equal to 1. So here is a little transition between probability to probability distribution, okay, so let's pretend we're going to flip a coin 2 times. The sample space of flipping a coin 2 times is heads heads, heads tail, tails heads, or tail tail. Okay, we know there's 4 possible outcomes when we flip a fair coin 2 times. So here I wrote, rather than asking for the probability of getting heads and the tails, we may only be interested in the probability of getting just heads. So the random variable x will now become just getting heads. And the possible value of getting heads got to be, I can get 0 heads, or I can get 1 head, or I can get 2 heads out of my 2 flips. So the distribution, okay, the distribution changed. So rather than count the frequencies, okay, of getting heads, now I'm actually counting the probability of getting hits. So what can I possibly get? Well, number of heads I can get is 0, I can get 1, or I can get 2 heads, right? So this is where the probability question comes in. I know I have 4 outcomes. I know I have 4 total outcomes, flipping coin 2 times. Probability of getting 0 heads simply means on the 2 flips, I get 0 heads. So the counting technique comes in as well. 2 choosing 0 heads. There's only one way up here. It's only one way to get heads, which is 2 tails. So the probability of getting 0 head is 25%, 1 out of 4. Probability of getting 1 head will be 2. Why? Because head and tail, tails and head. So 2 choosing 1 is going to be 2. There are 2 outcomes that I will get just 1 head. So that's 50%. So getting 2 heads means right here got to be 1 time. 2 choosing 2 got to be 1. So there's another 25% chance. Okay. So now this is what we so-called a probability distribution. The heads are my random variables. Okay. So basically your L1 becomes a random variable. Your L2 in the calculator becomes a probability of the random variable. All right. And these sum up to be equal to 1, of course. All right, the concept of expected value. The expected value for a discrete random variable x is equal to the mean of the probability distribution x, and is given by this formula. The expected value, this is the important part, the expected value of the random variable x will eventually equal to the mean of the random variable, will equal out to the mean. So we can actually figure out the mean right here. We take each one, we take each xi, which is a random variable, multiply the probability of that. So if I take 0 times 1/4, 1 times half, 2 times 1/4, let me do it right here, okay? 0 times 1/4, 1 times 2/4, and 2 times 1/4. This is 0.5. This is 0.5. Okay. And I sum and I add up everything I just multiplied. 0 times 0.5, 1 times half is half, 2 times 1/4, right? 2 times 0.25 is 0.5. So if I sum them up, that will be equal to 1. So the expected value is equal to the mean of the probability distribution. So let x1, x2, x3, so on and so forth to be the value of a random variable after each experiment. And lowercase n to be the number of experiments. So the mean, when we used to talk about the mean, right? When we talk about the mean, when we used to talk about the simple mean, it's basically add up all of them, right? So these x1, x2, x3 are the value of a random variable after each experiment. And we divide by so many, we added it. That will give me a simple mean. So here we're saying that eventually, if we add up all these, the simple mean will become the mean of the probability distribution of the random variable x. So as the number of experiment of n, the number of experiment n increases, then eventually your simple means will equal to the mean of, the population mean of the random variable. Okay, we kind of mentioned that at the very beginning of the semester. As the number of experiment increases, we will actually get closer and closer to the true mean of the population. Okay, so this is considered as an expected value. All right, so let me do some example of expected value here. Okay, so this involved with a little bit of probability. So let's say we throw 2 dice. If the sum of 2 dice is 5 or more, you're gonna win $30. If not, you're gonna pay out $161. So number one here says find the probability of winning. Well, we know rolling 2 dice, the total possible outcome is 36. Okay. You win if it's 5 or more. So the sum is 5 or more. So it's easier to figure out how many ways I can lose. So I will lose if I get sum of 2, sum of 3, sum of 4. All right, to get a sum of 2, I gotta roll 1 and 1. To roll a sum of 3, that gotta be 1 and 2, 2 and 1. To roll a sum of 4, that gotta be rolling a 1 and a 3, a 3, then a 1, and a 2 and a 2. So there are 5 ways to lose. So the winning got to be 1, 2, 3, 4, 5, 6. Excuse me. There are 6 ways of losing. So that means there are 30 ways I can win. So my probability of winning got to be 30 ways to win because there are 6 ways to lose out of 36, right? Total possible outcome. So 30 ways to win out of 36 total possible outcomes. Okay, do not simplify the fraction. Now I'm going to take the answer in number 1, multiply the amount of winning. So I take 30 out of 36 times the amount of winning. I win $30. So if I take 30 out of 36 times by $30, then I can win in a, $25. So basically what I'm doing here is basically similar to this table. I figure out my wins, my probability of winning, right? And then I know what I know my random variable, I know I win. If I win, I get 25, excuse me. I know if I win, I get $30. So I just multiply them together. Now I'm gonna find the probability of losing. Then I'm gonna take the probability of losing times by the money I will lose. And once I figure that out, I'm gonna add them all up. That's what this summation sign here represent. Then I will get my expected value. So probability of losing, that got to be the 6 ways I lose out of 36 possible outcomes. So I'm gonna take this number and multiply the amount of losing. Okay, losing $161. So when I do lose, I lose about $26. Negative $26.83. Okay, losing is negative on the money part, right? So I'm losing 26. So my expected value of my random variable X, which is winning and losing, will be $25 when I win, plus when I do lose, I lose $26.83. So if I add them up, that means I am expected to lose $1.83 every time I play. Okay, so that's a good example of a expected value. So you are expected to lose, okay, because a number and the reason is, maybe because the payout is not that good if you do win. Even though there's a lot of way to win, the payout is not that much. You're not winning much money as compared to the 6 ways you lose. And when you do lose, you lose $161. So in that case, when you do lose, when you play, you are expected to lose $26.83. When you do play, you are expected, you're expected to win $25. If you win, you're expected to win 25. If you lose, you're expected to lose 26. So overall, the expected value as we continue to play, many games, you're expected to lose $1.83. All right, try another one, okay? Same thing. Now this time is flipping a coin 12 times. If you get 8 heads or less, you win. 8 heads or less. So I know I can, flipping a coin, I can get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way up to 12 heads. Right? We will win if we get 8 heads or less. So from 0 head all the way up to 8 is winning. So losing is getting 9 heads all the way up to 12. And that's the part I don't want. So this problem is easier to find the probability or the number of ways I will lose and divide by total possible outcome. So my probability of winning, all right, got to be, all right. So the total possible outcome, flip a coin 12 times. So each flip has 2 outcomes. I'm gonna follow one followed by the other, do it 12 times, minus, okay, let's figure out the number of ways to get 9 heads. 12 flip choosing 9 using combination, plus 12 flip choosing 10 heads using combination, plus 12 flip choosing 11 using combination, 11 heads, right? So I'm figuring out what I don't want, subtract from the total possible outcome, plus 12 flips choosing all 12 heads, because I will lose on that using combination, and everything divided by the total possible outcome, 2 to the 12th power. All right, so the top is quite a bit of work, okay? So I'm gonna just tap out the top first. 12 choosing 9 plus 12 choosing 10 plus 12 choosing 11 plus 12 choosing 12. Okay, 299 ways I can lose. 2 to the 12 power is the total possible outcome. So that's 4,096. So 4,096 minus the number of ways I will lose. There are 3,797 ways I can win out of 4,096, right? So this is my probability of winning. So I'm gonna take this number, multiply the amount of winning. So 3,797 over 4,096 times by the winning. I win $4. If I do win, I win $4. 3,797 out of 4,096 times by $4. All right, so $3.71. So if I play this game, if I do win, I win $3.71. All right, probability of losing. So probability of losing got to be earlier. We figure out the number of ways to lose is 299. The total possible outcome, which is 4,096. I'm gonna take that number. Number 4, take the number times by the amount I will lose. And when I do lose, I lose $37. So 299 divided by 4,096 times by -37. So I expect to lose $2.70. So when I play this game, right? When I play this game, when I do win, I win $3.71, not $4, because there are ways I can lose. But if I do lose, I lose $2.70. So my expected value of win and lose got to be the $3.71, right? We add them up now, plus what I normally will get when I lose, negative $2.70. So 3.71 plus negative 2.7, that means in the long run, I should expect to win $1.01. This is a positive answer. So in the long run, I should expect to win $1.01 when I play this particular games. Okay. So that's the expected value. So if you ever play like a lottery, okay, like the Powerball, the computation is already set. Okay, the computation for probability of winning is already set. Okay, and the Powerball back in the day, I can't remember how much is it now. The Powerball back in the day is $2 per play. Maybe it's $3 now. The $1 to play the first 5 numbers, and then if you want to power it up which is playing the Powerball, you pay another $1. So the probability of getting the Powerball is already set, okay? Times by the money that you spent, okay? Then you can actually figure out the expected value. What do you expect to lose, or what do you expect to win in the long run? All right, let's take a look at homework. Question 1 and 2 are from the definitions. Question number 3, rolling the die. This time, it's a sum of 2 dice, 6 or more, you will win 47. If not, you pay 127. So follow the steps I just showed you earlier. Enter these answers into the computer using the graphical equation. Okay, so that's all the homework. So just real quick, kind of quick introduction of what is a random variable. Okay, a random variable is basically a variable whose numerical value is determined by the outcome of a probability experiment, and then kind of explaining how we can use the random variable X and the probability, and then to put them together, creating this probability distribution. All right, thank you for watching.